Josh es líder de UX, diseñador de inteligencia artificial e Internet de las Cosas. Es el fundador de Big Medium, autor de Designing for Touch, Tapworthy, Designing Great iPhone Apps. Un aplauso para él.
Very nice today. You look great. You look terrific. So I'm here to talk about how designers can work with machine learning and artificial intelligence, which I think is something that design as an industry hasn't really engaged with very much, that it's been sort of the domain of data scientists and algorithm engineers. And I think a lot of designers have sort of tried to figure out, I don't even see a role for this for me. And so I'm going to talk about that, but I'm also going to talk broadly about what does it mean to engage with a new technology and how do we approach that. So perhaps to start off, what I'd like to do is to look at what it often looks like or feels like to engage with a new technology, not just as a designer, but as a customer. I'm going to take you back about a year or two to this product called the Juicero. The Juicero, its big innovation was that it is an internet-enabled fruit and vegetable juicer. Yeah. It cost about $700 when it first came out. And it turns out, though, that the big innovation in this is not actually that it juiced fruit or vegetables, but rather that it juiced these little packets here, right? And it turns out after careful analysis that it didn't actually require the machine to do the juicing. That after about a couple of minutes, you could have the very same result with these instead. And you might say, well, all right, so I'm not quite sure that the internet-connected juicing is really a huge benefit, but hang on. It's not all the machine did. It also had these barcodes on the packets, and the machine could read the barcodes and let you know, for example, if it had passed the expiration date or other information that also happened to be printed on the back of the packet as well. So what you had here, essentially, is this very expensive, actually got knocked down to $400 by the end of all of this, because not a lot of people were buying it, but a very expensive gadget that actually served no real need and did no real work. And it turns out, actually, this is not a new thing. There's a long history of designer abuses in the kitchen. You might know this juicer, designed by Philippe Starck, and if you try to use this to juice a lemon, you'll just make a mess. But it's okay, because Philippe Starck tells us that he did not actually design it to squeeze lemons. It's meant to start conversations. That's some bullshit right there, right? This is pretty self-serving when our job is to serve others. This is about a fascination with the thing instead of the service that the thing might do. And I think that we all run into this a little bit as technologists and as makers. We get excited about some new technology or some new design pattern, something that we want to try and do, and we sort of impose that on our customers or on our practice for a little while, just out of that excitement. But I think that what we need to do instead is especially when we come into these new technologies, is be thoughtful about how we're going to apply them. The kitchen is full of examples like this. I give you the Wi-Fi-enabled kettle, which I know you all have been waiting for. Let me tell you a little story about a gentleman from the United Kingdom named Mark Rittman. He has one of these, and he went about setting it up. And it very immediately told him the kettle reported that it couldn't connect and asked to be recalibrated. And now 3 hours later, the kettle had sabotaged his Wi-Fi router and had slipped into some unknown nether region of his network, and he couldn't find it. So Mark is undefeated. He's now port scanning his network to try to find the kettle somewhere in there. 10 hours later, he finally has his cup of tea. He's got the kettle back online and working, but his family is sitting in the dark because the smart lights needed a firmware upgrade, right? So the internet was not particularly sympathetic. At this point, I'm desperate to avoid this future at all costs. And why don't you get a new darn kettle? Forgive me for the language here, friends. I'm just the messenger. All right, so here's another review of yet another smart kitchen gadget from Fast Company. It doesn't even matter what the product is, because at this point, I think we're all familiar with experiences like this. as customers and perhaps as designers, where we run into a technology or a product that's automated, it's supposed to make our lives easier, but it winds up distracting us. It boasts of great things, but it's mediocre. It's confident, but it just seems to be always wrong. And these are signals, not that we should abandon this new technology, but that we don't yet understand it right, that we aren't yet understanding how it wants to be used. And what I mean by that is, what is the grain of the technology? What are its strengths and its weaknesses? How can it actually improve our lives, bend to our lives, instead of forcing our lives to bend to the new technology? I think this is sort of something that Maritza was really bringing up too in her wonderful talk this morning. Is, a better way to think of it is, how can this add meaning to our lives instead of just adding additional technology? Or even better, how does this amplify human potential? Often we're trying to replace human activity. It's all about efficiency, replacing human judgment, replacing human agency. How might we instead do it in a way that actually amplifies those things? I think these questions are especially important when we enter into a new chapter of technology, and I think we're in one of those moments right now. It's an exciting moment and a slightly unsettling one, where we're getting the arrival of a new design material called machine learning. I run a design agency in New York City called Big Medium, and our focus is on design for what's next, helping companies figure out how to fruitfully and meaningfully use new technologies, follow those opportunities, or sometimes address the problems or crises that they introduce. For the last decade or so, a lot of that focus was on mobile. How do we sort of push the boundaries of what mobile can do? What does that mean as we all have these supercomputers in our pockets or handbags? But over the last couple of years, more and more of our clients have been asking, what do we do about data? What do we do with algorithms? How can we put this to good work and also stay out of trouble in the same time? I think that if mobile defined the last decade of digital product design, machine learning is already beginning to define the next. And so we have machine learning as a new design material. And what I mean by that as a material is that HTML and CSS are design materials. They want to be used in a certain way. Prose and language is a design material. Visual data or dense data is a design material. All of these things want to be used in a certain way, just as if you were working with wood. You want to understand the grain of the wood so that you're building to its strengths and working around its weaknesses. So that's what I'm talking about with a new design technology, is asking, when you get a new design material, is asking, what can it do? What is its grain? How does it change us? Not only what does it offer us, but what does it require of us? And sometimes those changes are not always perfectly intentional. But I think these are the questions to ask. And I think these are the three things, if it's okay with you, that we're going to talk about today. Does that sound all right? You guys doing okay? You look great. You look terrific. All right, well, let's start with this first one. What can it do? Or put another way, it's like, why team up with machine learning? And how can you think about bringing it into your everyday practice? The stuff that you're doing right now, the products you're already working on, and with tools that are already available to you. Why team up with it? What can you do with it? And the big promise of this is essentially, if we could detect patterns in anything, what might we do? How would we act on those? Machine learning, for better and worse, already drives so many of the interactions that we have every day. It determines the news that we see. It determines maybe the movies that we decide to watch, the products that are surfaced when we go shopping, the way we drive home from work. Sort of these algorithms are touching everything that we do, again, for better and for worse. And this is all the power, the pattern matching power of machine learning, surfacing generally useful insights, not always, but generally. So what does that mean for you and your everyday practice? I want to just talk about very briefly sort of 5 applications that you can bring into the products that you're already working on. I'll talk through these very quickly. Recommendations, fairly familiar. I'll use Slack as an example of this. About a year ago, they introduced a feature in their enterprise product for big teams to help you find people who talk about certain topics. So this is machine learning that helps you to find experts in your organization. If you need an expert in hiring process, Isabella is your go-to. So this is recommendation, very simple, a ranked list of documents that match a specific context or concept, in this case, people. This is closely related to classification, which I'll talk about in a moment, but also to prediction. By prediction, this is an example, right? Predictive Keyboards, another example of just everyday machine learning. The statistically most likely next word showing up above the keyboard. It's a simple intervention to speed the error-prone task of touchscreen pointing. And so that's prediction. Based on statistical, historical data, here are the things that are most likely to happen next. Prediction. Classification. Google Forms, which many of you are probably familiar with, Google's survey tool. When you set up a survey, there are, for each question, several, what is that, 12, 13 different answer formats that you can have. The default is multiple choice, radio buttons there. You can see the third one down. But there are a lot of options here. They've tried to make it as simple as possible as they could, but it still takes some time and thought to get it right. But look what happens when you start typing the question text and how that changes the answer format. How satisfied are you maps to a linear scale, 1 to 5. So they added just a little bit of machine learning to the mix to make this easier. So that the right question, it doesn't choose the answer format for you, but it's waiting for you when you get there. It changes it to a smart default. Which of the following apply? Sets it to checkboxes. So just sprinkling a little bit of intelligence into this form just to ease that process, make an intelligence suggestion. Not replacing your judgment on this, but giving you a strong signal is the right thing to do. It's going to sort of pause. I know we haven't gone through all of these different applications, but you might be looking at this and being like, this is not what I think about when I think about artificial intelligence. I thought we were going to talk about my sentient robot butler. I was like, this is not very exciting. And in a way, that's sort of what I want a big takeaway that I'd like you to take from this, is that there's a real opportunity just to sprinkle a little bit of machine learning into our interfaces that we use every day, almost mundane ways, into web forms, into the keyboards that we use. Machine learning, in other words, can be part of your everyday toolkit, part of the products that you're already building, just like we think nothing of sprinkling a little JavaScript into a page to add interaction. We now have the tools, and I'll talk about the ones that you're ready for you to use right now, tools that we can use to sprinkle a little intelligence into our pages, just as casually. So I think we need to get comfortable with designing for the algorithm. I mentioned, mobile has sort of defined the last decade of digital product design. Just as we're accustomed now to designing for small screens, we should be accustomed to designing for the algorithm. Again, in ways that are sometimes quite mundane and simple. Actually, it's a great place to start. There's sort of often low risk in those things. It's a great learning process, as well as adding, genuine but subtle value to your customers. So friends, you can quote me on this. Sprinkle a little machine learning on that. It doesn't have to be a big deal. It doesn't have to be the tentpole feature for your product. It can be something that, and should be something, that infuses all the things that we do. This is not magic. It's not beyond the means of your company or of you. And I'll describe some of the services later that you can use. All right, so let me just sort of talk about one more of these applications, clustering. This is the one that can feel either like magic or nonsense, depending on the results that you get. It's completely unsupervised. The machines just go out and find patterns. So this says, these things are different from the average in these common ways. That's a cluster. Here's another group that's different from average in these other ways. That's another cluster. So it's classification, but it's done by machine logic instead of human logic. In that Google Forms example, those were sort of machine or human-generated categories. That humans had generated those 12 or 13 categories and trained the machine to find those. In clustering, the machines define the categories. And what that means is it lets us identify these invisible patterns, things that we normally wouldn't see either because of the scale of the data or the frankly weird ways that the machines see and understand the world. So this is a way in which we can identify things that depart from the average, from normal, in certain specific ways, like fraud or crime or disease, spending outside of your normal pattern. Groups of data points that sit outside the norm in an interesting way. And it can also be used to find clusters of behaviors or new customer segments. So new sort of flashes of insight. I'll talk about generation and give you an example of that in a moment. But these are sort of 5, again, applications of machine learning intelligence that you can bring to your products right now. Before I get into generation, I want to take a look, though, first of what happens when you point these abilities at the kind of work that we do as designers. You might recall Quick Draw from Google. This is basically Pictionary, the game where you sort of you're prompted to draw a picture and your teammate has to guess what it is. This time it's the machine guessing what it is. So let's give it a whirl. We'll give this a try. And it challenged me to draw a mountain and see if it can figure it out. This one's pretty easy. Oh, I know, it's a mountain. Piece of cake. All right, try another one. It's a square, it's a triangle, elbow, dishwasher. It's a calculator. Oh, pretty fast. And now we'll try a hamburger. It's a shoe, hot dog, hot tub, bread. It's a hamburger. I didn't even get a chance to draw my little mustard on top. All right, one more. This is a flip-flop or a sandal. It's a peanut. It's flip-flops. Sandals. That is not a flip-flop. That has nothing to do with a sandal, right? It doesn't look anything like it. But let's see sort of what's going on here. We can see what it also thinks it looks like. It turns out that this drawing of flip-flops is very similar to both potatoes and bread. If we see what other people drew, they did a little better than I did. A little bit more realistic, but none of these things really look that realistic. If you look at them all together, what you really see is, oh, this is a symbol for a flip-flop. An oval with a little arrow in it is the symbol for flip-flop. And so the machines are learning not how to identify the actual thing, but the symbols, the notations that we use. And if you think about it, we use a lot of notations in the work that we use too, right? What happens if we teach the machines to understand these? There are a lot of projects like this right now. I'll show you one called Wizard. I think it's Wizard, U-I-Z-A-R-D, UI, like GUI, Wizard. You decide. Wizard.ui.io, excuse me. So this is an example of both classification and generation. I promised I'd show you some generation, which is the idea that the machines can make something themselves, generate their own work. So in this case, this is a web app, and I just take a picture of this sketch that I did. As you can see, it's a very simple sketch. It's just like a little inbox. And about 30 seconds later, it'll process it and it'll be ready. Take you to the web view of this, and you can see on the left, here's the sketch that I did, and in the middle, here's the interface that it generated. It did pretty good. I've got 2 search boxes here for some reason, but otherwise it did okay. And it generates both Sketch and HTML files. The HTML is actually pretty well formed, unlike a lot of these other tools, well formatted. But let's go in and see what happens if we look at just the Sketch file for now. We'll open this up in Sketch. You can see, great, here it is. And as you explore it, you can see, oh, wait, this is text. This is editable text. You can go in and sort of change that up. Here's a little thumbnail image. I can just drag that around or resize it as necessary. You can see actually, too, that these are grouped as a row, so it understands those are logically go together. If I just double-click into this, I see, oh, wait a second, these are sketch symbols. I see what it was doing. It has these prefab components that it has taught the notation to the machines for what maps to what, and just sort of drawn them in. Now, the problem is this is not your style. This is also a little bit brittle. It doesn't work super accurately all the time, as we saw with the 2 search boxes. And again, this may not be the way that your stuff looks, your components look. But what if we could start to actually teach the machines how to map things to the components you've already designed? In other words, to map those notations to a familiar vocabulary of, oh, this is our input form. This is our hero image, etc. It turns out when we do that for humans, we call that a design system. And design systems establish standard patterns and a common vocabulary. And if you've established that for humans, well, then why not share it with the machines? And again, the idea here is not that it's like, oh, this is going to be ready to go to production, but you've done sort of a quick scaffolding to get a prototype very quickly from Sketch into the browser. Didn't show you the HTML part of that, but you can get right into the browser. Just bring the design patterns right in. And if you've established that vocabulary, then maybe you don't even need the sketch, that original paper sketch in the first place. Maybe we can just say, hey, Alexa, I would like an interface, please. A few of you might be saying, wait a second, that sounds a lot like my job. That sounds a lot like what I do. I would say that is part of your job, but it's the least interesting part of your job. Your real job is to understand, what is the problem I'm trying to solve? And if we have a design system, do we have components that already solve that problem? Which components are correct? How should we mix and match those? And more crucially, what's the new work that we need to do that's not yet solved? You are problem solvers. You are not people who transcribe paper sketches into sketch files or sketch files into markup. That's frankly, the clerical part of your work. And it's often work that is time-consuming, repetitive, and detail-oriented, and error-prone, and joyless. You know, the stuff you get up in the morning excited to do. But the robots love doing this stuff. They're great at it. We hate doing stuff like this, but the machines are great at it. So what if we let the machines focus on those things so we can do the things that we are uniquely good at? I'll give you an example. We've been doing some work with a healthcare company, and they were zeroing in on ways that they could help radiologists do their job better. The people who look at x-rays and images looking for problems. Their job doesn't actually look like this. It looks a lot more like this. Oh, with me on there, it's like, I've got even more of them. This is great. So much of their time is spent looking at scan after scan after scan, most of which have no problems in them, right? But that's not the part that's using their actual expertise, which is when they actually find a problem and identify it and figure out what it means for the patient, and perhaps in some cases have the actual conversation with the patient about the meaning for that, or at least with their colleagues, other doctors. That's where their expertise comes in. The other stuff is just triage, looking at empty images. So instead, what we were able to do is to set up a system where the machines could, using computer vision, identify problems. Very high level of sensitivity. We don't want any false negatives. We don't want anything to get by. But basically what it means is the machines are bringing interesting cases to the doctors, focusing their attention and judgment on the cases that matter, and saving their energy and creative powers for the things that are important. So strong signals to where they should focus their attention, not replacing their judgment, focusing it. So the idea here is that how can we let people do what they do best by letting machines do what they do best, because they are almost never the same thing. We're not trying to replace people in this. We're trying to amplify their ability to focus their attention and judgment. So if we can clear away the noise and help signal where we can do our most interesting and creative work, that's the real opportunity for machine learning. So if we think about this opportunity of being able to detect patterns in anything and then acting on them, I would suggest that there are sort of 4 different ways that we can think about this, problems that we can solve, new powers that we can bring to bear. So I mentioned 5 applications. I want to talk about 4 categories of problems. And the first is maybe the most obvious and perhaps the least interesting, which is how can we use classification or clustering to understand the conceptual relationships between documents or people or trends, to be smarter with questions that we already ask. That Slack example was one of them. So instead of doing a brute force search through all of the posts that everyone has ever made in Slack, trying to find out who talks about a certain topic, Slack has clustered all those posts into concepts, so we can search about the concept that people search for. So in other words, it's just smarter about being able to answer questions that we're already trying to ask. It gets a little bit more interesting, too, when we think about entirely new kinds of questions. If you work in a customer service center and you're dealing with lots of emails, this is, again, instead of searching just by the text, you can now search by emotion, right? The machines understand sentiment. Or I want to search by urgent messages from customers or angry messages for customers. I want to start my day off early. I would like friendly, kind messages from customers. Everyone would like that email filter, right? New kinds of questions. Also the ability to unlock new sources of data. The machines are suddenly able to understand all of the messy ways that we communicate as human beings. So they can understand our speech and our handwriting, our doodles and sketches, our photos, our videos. All of this stuff used to be completely opaque to the machine. Now they can understand them. What are the opportunities of having that as a data source, but also perhaps as a surface of interaction, which is what we're seeing with all of the speech assistants, or augmented reality with computer vision. What are the opportunities with having all these new sources of data? And the last one I'll mention, and it's related to clustering, which I talked before, is this idea to surface invisible patterns, to see things that we hadn't been able to see before, new groups of customers or behaviors, perhaps early diagnosis of disease. So if you map those 4 categories of machine learning smarts against those 5 applications that we were looking at, then we start to sort of understand the possibilities. Where might artificial intelligence and machine learning actually be useful and meaningful? And frankly, friends, that's the job of UX, right? Is where can we point technology in meaningful ways that amplify our potential and what we want to do? That's the opportunity. I think a lot of times we're still aiming the technology at problems that aren't worth solving, or that actually get in our way, or replace our agency in ways that they shouldn't. But the opportunity for us as designers is to figure out where in this customer journey, what narrow slice can we replace? And designers, maybe it's transcribing the components we've drawn into a sketch into the components that we already have in our design system, that little narrow slice of it. Or for radiologists, doing the triage on those images. What is the human need, and how can machines help to solve that need? All right, so that's what machine learning is for, and I'm going to spend most of the remaining time here talking about the grain of machine learning. And what I mean by that are, what are the unique qualities of this design material that gives us cues about how we should work with it? What are its strengths or peculiarities? More important, its weaknesses. What are the problems that it could introduce and is already introducing? And with machine learning and algorithmic interfaces, as Maritza already alluded to earlier, there are a lot of problems that we're already seeing. This could go horribly wrong. And for designers, we need to understand the texture and dangers as well as the opportunities that this has. So let's take a look at what this means. There are a lot of peculiarities about machine learning. I'm going to talk about 5 of them today. And the first one is, man, the machines are so strange. They are truly weird. They study the world, they sift through enormous volumes of evidence and data, and they come to what I think we could all agree is sometimes very surprising conclusions. Here's an example. It takes about 14,000 brain hours for a human being, a baby, an infant, a toddler, I guess, to learn to run. An artificial intelligence can figure out how to run in less than half as many CPU hours, but the results are like this. Sort of using the arms for forward momentum with little consideration of the physics of friction or the realities of our rotator cuffs and joints. But then again, we also come up with strange approaches to locomotion. Just consider the Prancer-size craze of 2013. Straight out of Florida, this took the world by storm. I'm sure you all were doing it just a few years ago, getting that exercise in. When people are so difficult to understand, so often unpredictable and eccentric, how can we expect the machines always to make sense of what's happening? So my point here is, if the machines are weird, it's really because we are weird. They're like learning our data, all of our eccentricities. They're trying to figure out what the heck is going on. We are not always very consistent or understandable. We communicate in ways that aren't always predictable, or that themselves are somewhat fanciful. You know, what are the machines to make of us as creators or artists? This Renoir painting is in the Barnes Foundation in Philadelphia. And the curators there ran their whole collection through a computer vision algorithm for identification. They were curious to see if it could help to tag their images, for example. So the robots came in, and they confidently identified this image as a boy holding a teddy bear. Nailed it, right? Totally success. And you might say, it's like, okay, I guess this is a bust. We can't trust these machines for anything. And I think that it's true that what you wouldn't want to do is sort of automatically put alt tags on your website with this information in here without taking a look at it. But they didn't actually strictly see this as a failure. When they asked a neural network to find cherubs in their collection, little angels, it found things that were definitely not cherubs, but yet were also similar to cherubs. And so the curators began to find these interesting connections in their collection that they hadn't seen before, because the machines doing this clustering work that we talked about before had organized their collection in ways that didn't map to the ways that art historians think about schools of art or periods of art, or even media. Instead, they started to find these collections, and it created some productive and creative friction for the curators. Shelley Bernstein led this machine learning effort, and she described these connections as magic. It's sort of something that you want to keep because it generates new insights. So the point is that sometimes it's useful not to take the results of these quite so literally, but to sort of just kind of almost get a second view of what your data is doing. So this is the first lesson here. The machines are weird, so draw insight from the unexpected. A productive friction, as I mentioned before. The patterns and connections, they make surface themes that might otherwise be invisible to us, the unexpected. Let's talk about unexpected visitors. BJ May is a gentleman that has one of those Nest doorbells, you know, the creepy ones with the cameras, and you can talk through them, and sort of like a little, your own private surveillance device on your front porch. He had set his up to do something special, which is to lock the door if it didn't recognize someone. And one day, it locked the door on him. And so we went in there to see what was going on. And what he saw was that the system was like, do you want to let this guy in? Because he seems kind of angry. I don't think he belongs in the living room, so we're just going to keep him out. Well done. Well done, Nest. The machines perceive and interpret the world in ways that are different than we do. We often sort of assume that their computer vision works the way that we think it does, or that they have a common understanding. It's not at all true. They see the world totally differently. So weirdness and unpredictability and mistakes are essential to this design material. So the more that I work with machine-generated results and machine-generated conclusions, and especially machine-generated interaction, where the machines decide how to respond to the people, the more that I realize I'm not in control of this experience as a designer. And that's new for me. I'm accustomed to designing paths through information that I control. And now we're designing not for success, but for the happy path. We have to design for failure and uncertainty. How do we anticipate mistakes and a fuzzy range of results and confidence in all this? And the confidence part is important. I'll talk about that in a bit. You know, this is really what interaction design is to me, is how do we sort of help people to use technology to get a desired result? And a lot of that is about setting appropriate expectations about what that technology can do in the context of what the human being is trying to do, but also to channel behavior. And so specifically, how do we set appropriate expectations? And how do we channel behavior in this context in ways that match the system's capabilities? How do we do that? I recommend BaseApp. Be as smart as a puppy. And frankly, that's about how smart these systems are. You know, we sort of have lots of science fiction visions of this as being sort of like the uber intelligence that is going to take over the universe. We are talking about puppies at this level, right? This is a phrase from Matt Jones of the late, great digital agency in London, Berg. And that agency was a pioneer in connected devices and frankly, a lot of digital weirdness. And he came up with this way to think about creating honest, gentle interfaces for these weird systems. He said, our goal should be making smart things that don't try to be too smart and that make endearing efforts in their attempts to learn and improve, like puppies, or maybe robots.
Too elusive. Can it contain him?
Snapping ankles along the way.
Run again. This run is uncontainable.
Drops in.
Goal!
All right. You didn't expect much from these guys, did you? There was sort of like a manner and presentation that it's like, I understand that this is not going to be world-class soccer play, football, excuse me. To help us anticipate and forgive and recover from error, we need to sort of have the right manner about that. It may sometimes be annoying. Even puppies can be annoying. But it won't surprise us, or at least endanger us, if we set the right expectation. Too often, though, when machines make a mistake, it simply feels more like this. Ah! Just a doll. Just a doll. No babies were harmed in the making of this presentation. The expectation is, hey, little baby, you want some delicious milk? And that's the way it feels, right? And that's about the design, not just the the engineering error that this made, but the presentation and expectation that it sets. How do we cushion mistakes? How do we set expectations? How do we establish an appropriate level of skepticism for systems that are still fragile? So I think a lot of this is about matching the language and manner to the system ability, and that is about presentation, that is about design. Alexa and Siri and Google Assistant, they all overpromise. They all set the expectation, ask me anything. And as incredibly capable as these systems are, they fail incredibly frequently at that basic expectation. They front as nearly human assistants, and they invite us to ask anything, but as capable as they are, they set expectations that they just can't fulfill. So they might be better off with base app. Be as smart as a puppy. And I don't mean that your mission critical systems have to be adorable and cute. It's more sort of like, let's be transparent about their limitations and what you can expect from them, and where human judgment is going to actually do much better than what the systems can do. Here's a system that also has trouble with its kind of false level of confidence. This is PickDeskBot, a Twitter bot that takes images from Wikimedia and then puts them through Microsoft's image recognition service and just shows the machine-generated description. And here, this is pretty sophisticated, right? This is a complex image. The language is almost poetic. It's a herd of cattle grazing on a lush green field. It's kind of cute when it gets confused, a person holding a cell phone. I don't know if you guys have seen the latest Samsung model. They just keep getting bigger. There have been a lot of studies, actually, about machine-generated descriptions and how to handle mistakes in them. And it's probably common sense, but the result of these is often that it is better to be vague and correct than overly precise and wrong. So, we're saying now a person holding a cell phone, something that is more correct but decidedly more vague is a person holding an object, which is better if you want to sort of give this description to someone who is, for example, has a visual disability and is unable to see the image. But what is implicit in this that we're not seeing yet, and I'll show you some examples of how this data comes through, is that the machine probably has a number of things that it thinks that object could be. We saw that it was a cell phone. Why don't we actually sort of surface that as one of the guesses that it might have? This is an object, but I have a low confidence signal that this could be a cell phone. And the way we would say that is like, the person holding an object that maybe a cell phone, or maybe a guitar or a violin. And what we're doing here is we're making some suggestions, but in the manner and presentation, we're also suggesting that the customer, the person who is reading this, should engage some healthy skepticism in this. We're engaging their judgment in this. We're giving you a signal, but also acknowledging that there might be a problem with it. I'll talk about understanding and managing confidence a bit more later. It brings us to this idea of narrow domains, the second thing I want to talk about in the grain of these systems. Is that these systems have a very narrow understanding. They know very little outside of what they've been trained on, nothing really. CycleGAN is a tool, a neural network, that's trained on pictures of horses and zebras, as well as apple and oranges, so that to transform one to the other. So a picture of apples becomes a picture of oranges, or boom, your horse is a zebra. Sometimes it gets a little mixed up, a little buggy, so it gets confused when you run pictures that don't quite fit the model. So boom, Vladimir Putin is a zebra. But also look at the rocks behind. Everything is a zebra, right? It only knows horses. So if everything is a horse, right? It's a narrow problem. So again, this is not real intelligence. This comes back to what I was saying about the puppies. This is pattern matching on a highly specific domain. It's not intelligence. It's not expertise. There's no logical inference. There is no deduction. This is simply pattern matching at a vast, but ultimately very childlike scale. I like this quote from Benedict Evans, says, this gives you infinite interns, or maybe infinite 10-year-olds, which is interesting still. Maybe not, 10-year-olds might be able to give you some rough idea of what's in the image. Interns might be able to say, this is interesting. We're mostly at the 10-year-old level still, right? 10-year-old puppies. So because of this, right, is that we also have to be realistic about these things. These things are best at solving narrow problems, which is why I was introducing those mundane examples before. But narrow problems don't have to be small problems. We can see these things solving, this narrow slice of information around making sense of the climate crisis, or of the evolution of epidemics, or of general health care. Deep Patient is a system that was trained on hundreds of thousands of patient records looking for medical patterns. And one of the things that it quickly turned up is that it was able to diagnose the onset of schizophrenia about 2 years before human doctors. You might say, wow, this is amazing. This is a challenging diagnosis for doctors to make. And if this is sort of giving us insight into how to diagnose this is amazing. Except that we don't know how it works. All we know is it goes ka-chunk, 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 ding, schizophrenia. Right? So we don't know, it can't explain any of the patterns. In fact, there's no way to sort of go in and understand how it came to that conclusion. Even the people who don't know, even the people who made the system don't understand it. So if we don't understand where information came from, can we really call it knowledge? That's a big existential question. But it's something that I just want to use this as an example to say that it can be narrow problems, but it can also be important problems at the same time. But this example that I'm mentioning brings up this third area of the grain of machine learning, which is just that the logic is opaque. We don't understand, especially with the most sophisticated models, how they make their decisions. I'm going to bring this back to a simpler example. And friends, I feel like I am now close enough to you to share this about me. Many of you probably use Spotify too. The Discover playlist feature, kind of remarkable. It's like, wow, yes, it's recommending music that is a lot like the music I sound like. This is great. Whenever I listen to it, it sounds like this. My Discovery playlist is deeply uncool. It's all like dad rock. And the thing is, it's right. I am that uncool, right? I wish I was cooler. In fact, I'm embarrassed. I actually care, I think, what the algorithm thinks of me, or more to the point, maybe I don't like the reflection that Spotify shines in the mirror for me. So I try to change it. I don't know if you guys do this. I'm like, I better listen to cooler music this week. I gotta sort of skip this song. Except I don't know what's gonna happen if I skip. Maybe I'll never hear this again. I know it's watching what I do, but I'm paralyzed. Because if I skip, maybe I'll never hear this again. I don't understand what the model is, right? So a big thing that we need to do, and I think this is true for any application, but especially challenging for these systems, is part of our obligation together is to create data literacy. How does not only our service work these days, but also how does the internet work? Educate our users about when data is being collected, how that data is influencing their experience, and how they can also have some agency in it. So a quick example, I'm just really riffing here, back to Spotify. The interface should give some explicit feedback to indicate how skipping a song affects your profile, if at all. So just a silly example, really. We could show, it's like, you know what, you just skipped this. You have the option to remove the song from your history, which suggests that it hasn't yet, but also gives you the agency to do that. There's a little thing that does two things. One is give a little transparency into how this is or is not affecting how it understands you, but also lets you participate in that as well. What are you optimizing for? Signal your intention. And you can do that in the interface, certainly. When are you capturing information, and to what end? Be transparent. Signal when you're capturing that information. Find out how it's being used. And this is a core problem, because transparency is not a core value of our industry, or at least not of Silicon Valley. If you're an Android user, and you have Chrome running in the background, and you just let it sit. You don't even use the phone. You just put it over here, go over to the other room. You don't use the phone. You just let it sit there. My phone, with the browser running in the background, is sending my location information 340 times an hour back to the mothership, just about every 10 seconds, when I'm not even using the phone. That is not advertised to me. That is not something that is understood by the typical Android phone user. Facebook gathers your information from your friends' contacts, right? So they're building an ad profile of you even if you are not on Facebook. You're giving up your friends just by using the service. And worse, when you give your phone number for double authentication, for security to Facebook, Facebook makes that phone number available for ad targeting. So if an advertiser has a database of phone numbers, they can give ads specifically targeted to you, and you thought you were signing up for security. Quietly harvesting data any way that they can. You might think it's like, well, if we surface that, people probably won't want to use our service. And if you think that people won't like something you're doing, and I want you to come in closer and listen to this, maybe you shouldn't do it, right? Yeah, there you go. There's a couple there. All right. There's a lot of stuff that the industry in general is learning about responsible data gathering and transparency around this. I will say that a good rule of thumb is that if Facebook is doing it, do not do that. I think Facebook has a lot of good people in there that are trying to turn the ship. I believe that Facebook is a rat-infested ship built out of material that is cynical business models, and I believe they are irredeemable. So don't do what they do. All right, I have opinions. Make transparency a default design principle. And I think part of that is also sort of being clear about what is the system optimized for. Being clear about that not just with your customers, but with your team. What are we trying to do here? What are the things that we want this system to deliver and act on? But also, what are the values implicit in this? Are we, if we're Facebook, optimizing for growth and data gathering at all expenses, including our customers' privacy and safety? Well, then let's be explicit about it so we understand what bastards we're being, right? We can have a conversation. It's like, I guess, are we that company? I guess we are. But have that conversation. Be explicit about it. One of the things, though, about being explicit about what you're optimizing for is because the logic is opaque, it helps you to be able to at least measure how well your optimization is doing, right? Measure the results. Is the system delivering on what it's optimized for? And is it possibly undermining other things that we care about but aren't explicitly being optimized? Fix the systems when they don't hit the marks, but celebrate and improve them when they do. We might not always or even ever understand how these systems think, but we can at least look at and compare their results, and we should do that. One of the things that's strongly related to this is this fourth element of the grain of machine learning. Machine learning is probabilistic. We like to think that these things deliver answers, but they do not. The machines do not see things in black and white. They see a whole spectrum of gray. These are statistical systems. Nothing is fixed. It's all probabilities. And its algorithms are explicit about the confidence that they have in their predictions. And I encourage you to actually dig into this and see what it means. There are a lot of different services. This is Microsoft's Cognitive Services directory. At the same time that all the big companies, Microsoft, Google, IBM, Amazon, are competing to create the best algorithms and machine learning services around these kind of consumer applications like vision, speech, language, and so on. At the same time they're doing that, they're also competing to give those services away, essentially for free. If you have a hosting plan with any of those companies, you can also get access to some of these services. Microsoft's Cognitive Services is actually a really good place to sort of dig into it. They have a lot of web demos. You can just upload data, an image, for example, and get other data back and see how good these systems are at what they are and how they structure it. I'll give you an example. I am just self-absorbed enough to do this example with a picture of me. All right, so we'll give this to their image recognition service and see how they did. They actually did pretty well here. We've got a man looking at the camera with a confidence of 89%. It's pretty sure that it's a man looking at a camera. I confess I'm not totally comfortable with some of their things, like older, all right. I'm not gonna take that personally. Or, come on. I'm working on it. It's the one that's gonna stick with you, right? All right. Let's look at the percentages to see what's happening here with the confidence. We see here that it's really confident that this is a person, 99.9668% positive. He was like, that's a super strong signal. Man, indoor, and down here at older, only 28% confident that this is an older man indoors. I'll take it. I'll take whatever I can get at this point, right? It's not entirely wrong. If we look up here at the top, you see that it sorts the tags by confidence. So person, man, indoor are the most confident. And happily down at the very bottom, elephant. Which means it's not sure about that one. It's a guess. Right? With both older and elephant, it would be wrong to display this is an older man who's an elephant. It's more sort of like, I don't know, it could be an older elephant? The manner is important, as I was saying earlier. we have confidence levels here that we can sort of start to actually express how confident are we in the answer. Language, as I was saying earlier, is one way that we can get at that. A lot of times, though, we do things like this and sort of show the percentage confidence, just surface it like that. I don't know why I'm such a high match for Angry Birds. I feel like I'm being very vulnerable with all of you right now with my Spotify and Netflix accounts here. In usability testing, I often see that people just glaze right over these numbers. Either they don't mean anything to them, just don't even see them, or they don't understand them. What does 72% mean? What is that relative to? So those numbers aren't really well absorbed or understood. So again, kind of coming back to this, using language, using other different means of ways of to sort of engage people's trust or skepticism is an important thing to do. In applications like this, the stakes are pretty low, but there are other places where the stakes could be much higher, like law enforcement. We're starting to see the police in the United States and other countries using face recognition algorithms or pattern matching for predictive policing or to identify, pluck people out of crowds, out of surveillance. And that's serious. Are the machines up to it? The American Civil Liberties Union ran photos of Congress, the United States Congress, against a data set of 25,000 mugshots and got 28 matches. So Amazon has proven with science that the United States Congress is a bunch of crooks. But let's look under the hood here. The ACLU left the setting to the default, which declares a match when there's 80% or better confidence. And Amazon countered. They were not happy about the press they got on this. They said, whoa, we tell police departments to use at least 95% confidence. This is a probabilistic tool. And you have to set the probability to the seriousness, to an appropriate level of seriousness. But in a way, that makes the ACLU's point. The machines require careful tending and understanding, not just by those of us who might be close to those systems, but for the customers who use them. How do we surface that? I will tell you that I don't know is better than a wrong answer. My wife tells me this all the time. Especially a hurtful or hateful answer, an awful answer. But I think I know can even be powerful. Maybe an older man, could be an elephant. How do you suggest it instead of saying this is an older elephant, this is a criminal? The thing is that algorithms themselves are pretty clear about their confidence. They often honestly report that they're guessing, but our interfaces don't reflect that. This is a design problem. This is a problem of presentation. Responsible presentation of algorithmic data is as important as the underlying algorithm itself. The systems are smart enough to know when they're not smart enough. We as designers are not yet smart enough to surface that. So the results are probabilistic. So we have to present that information not as answers, not as absolutes, but as signals. I think I know. All right. This is important too because there are always signals that are relative to a baseline, which brings up the last thing I'll mention here with the grain of these things. The whole point of this kind of algorithmic pattern matching is to identify what normal is and then predict the next normal thing or departures from normal, disease, crime, fraud. Now, as Maritza mentioned earlier, she was like, I'm a little uncomfortable with the word normal, and she should be. What is normal? What does that mean? Does it change over time? Whose normal are we talking about? When you give Microsoft's image recognition service this picture of David Bowie, it says this is a woman. In the United States, at least, we're having a real cultural moment here, a conversation about what is gender. Is gender binary? Understanding that perhaps there's a spectrum here, that normal may not be so fixed, neither gender or in sexuality. How are the machines supposed to understand this changing set of cultural norms over time? How are they supposed to understand this when so many humans are having a hard time figuring this out? So what if our definition of normal is entirely wrong? What if our machines learn from us our own bad or dubious choices? What if they absorb and reinforce existing inequalities or leave out entire categories of people? We saw this with Amazon about 6 months ago. It was reported that they were using a machine learning service to go through resumes, find people that they wanted to hire, perhaps consider for promotion, and it was biased against women. And Amazon, to their credit, were like, whoa, this is not what we intended. We should pull this. They had optimized for some things, but in doing so, inadvertently optimized against something else they cared about, which is diversity and, in this case, gender equality. This is hurtful. This is damaging. This is dangerous, right? If there is a silver lining to it, and I'm not trying to sugarcoat this in any way, but surfacing bias could be useful. The machines surface bias naively, in a matter-of-fact way, without trying to hide anything, without embarrassment. They make obvious what's always lurked beneath. So they reveal the problems that we have to solve or address. Maybe in our models, maybe in our culture, maybe in the limitations of our own professional circles. So when bias is revealed, we can at least act on it. It gives us signals for necessary change. So it goes back to that measure, measure, measure thing that I mentioned. So just a few things here that are kind of unique to machine learning that suggest both its strengths and its weaknesses, its peculiarities. And the last thing that I'll mention here, I'll just do this very quickly, is just to ask, how does this change us? What intentions shall we bring to this technology? And how willing are we to consider that things will go wrong, that the technology will have unintended consequences? So it's not just a question of what do we want from it, what do we hope it will do, but what is it going to require of us as designers, as a culture? Does it change us? Beyond the interaction, what is the larger outcome that we want to see? And I will be clear, it is important that we are intentional about this, because these systems are powerful and strong and can suggest actions that we don't actually want to take. So what is the intention? What do we want to optimize those for? That is up to us. If we don't decide, the technology will decide for us. And friends, we do not want the future to be self-driving. Otherwise, it's the technology that runs the show. It's the tea kettle holding our families hostage while we work hard to restore its network link to normalize their life and keep the kettle happy, right? So let's be explicit about the vision that we want. What if, when you're sick, the machines handle the diagnosis, look at your symptoms and tests, determine what's wrong, and suggest a course of action? That would be abject if it stopped there. But what if, instead, the doctor could come in, and now they have more time, not to do the analysis, the machine has already done it, but to talk to you about the problem, to understand the meaning, to answer your questions, to have a real compassionate experience. In the United States, at least, I tend to get about 5 minutes with my doctor, tops. If that could at least be a compassionate 5 minutes, I'll take it. But because it may not require as much training, perhaps that job doesn't require as much education. Perhaps healthcare can be a little bit more affordable or create more jobs. If we go into this as the intention, instead of let's replace jobs, let's efficiency at all costs, what if these are the vision that we want to have? So my point here is that instead of humans working for the machines can amplify our potential by doing our joyless work for us and delivering new insight from us. And that, friends, is up to us. We are doing that here together. We are in charge of these decisions. We have more power than we know to frame these conversations, decide what we're optimizing, what are the values we want to do. This could go sideways in lots of ways, but I am optimistic, and I choose to be excited. There are a lot of these tools here now available to you right now in your everyday work, in the products you're making right now, to do amazing things. And I encourage you to do that, to make something amazing. If you're interested in more on this, point you to mindfultechnology.com, which is a movement about creating technologies that focus attention instead of distract it. uvetagenda.org is the output of a retreat that I was part of, framing the questions that we need to ask as designers about machine learning. And bigmedium.com is my agency's site where you can find more writings and videos about this topic. And I am here for the rest of the day, and I want to meet you, all of you, to answer your questions and talk about this stuff. So please find me out. I'm the older elephant out in the lobby. One thing left to be said.
So let's stop talking and do some walking.
Thank you very much.